Evaluating and assessing the quality of multiple choice question exam by performing several different statistical and mathematical analyses in SPSS and Excel. The first analysis is the reliability test. 3 different methods will be used to assess the quality and the reliability of the exam. The first method is the Cooder-Richardson Formula 20. The second method is the Cronbach's Alpha. The third one is the Anova Table. A second analysis is the item discrimination to determine which question can discriminate between high-performing students and low-performing students. 2 different methods will be performed. The first one is the Kelly's equation method. The second one is the point by serial correlation coefficient. The third analysis is the item difficulty to determine which question is easy and which question is difficult. All the analysis will be performed in SPSS and Excel. Calculating reliability for multiple choice question exam in both SPSS and Excel software. 3 different methods will be used to test reliability. The first method is Cooder-Richardson Formula 20, KR20. The second one is the Cronbach's Alpha formula using Cronbach's Alpha formula. The third one is based on Anova Table to calculate the reliability. All these 3 methods will be performed in both SPSS and Excel. 3 methods for testing reliability of multiple choice question exam paper in SPSS. The first method is Cooder-Richardson Formula 20, KR20 to test reliability of an exam. The second method is Cronbach's Alpha formula, and the third method is based on using the Anova Table in SPSS. Reliability test for multiple choice question exam in SPSS using Cooder-Richardson Formula 20, KR20. The test measures the internal consistency of items and score consistency. If a group of students repeat the same exam with the same questions in 2 different occasions, the scores on both occasions for each individual student are similar, and that indicate score consistency. And the formula to calculate that, the KR20 is equal to K divided by K minus 1. K stands for the total number of questions, and then multiplied by 1 minus summation of P multiplied by Q. P stands for proportion of the correct answer, and Q proportion of the wrong answers for each question, divided by the variance for the total score. Here I have a data from an exam result for 10 students answering 15 questions, multiple choice questions, and the score for each question was recorded as 1 for correct answer and 0 for wrong answer. And to calculate the reliability value for this exam, we need to do a KR formula 20 and use this formula to obtain the reliability value for this test or exam. There is no straight command in SPSS or function that can calculate the KR20, and we had to calculate each component of the formula one by one. So the first step is to calculate the total score achieved by each individual participant or student. And the way to do that is to click on transform, then click on compute, and in the compute window we're going to generate a new target variable. We're going to call it total score. And in the numeric expression we are going to add all the values achieved by each student for all the 15 multiple choice questions. So we select question number 1 and move it to the box in the numeric expression, then add the plus sign, and then we do the same thing for question number 2, and then we add the plus sign, and so on until adding all the questions from 1 to 15. Twelve, 13. Going to add 13 here, and then add 14, and finally plus sign, and then 15. And if we click on OK, a new column will be generated or variable called total score, and the value in it is the addition of all the scores for each individual participant. And I'm going just to decrease, if I click on the variable view and decrease the decimal to 0, so I get numbers of total score in this format. Now, once we have calculated the total score, the next step using the equation here is to calculate the variance for the total score. And to calculate the variance for the total score is to click on Analyze, then scroll to Descriptive Statistics, Frequency, click on Frequency, and we're going to move the total score to the box variables, and in the statistics we're going to select under, in this square here, click on the variance to select the variance for these variable or these data. And if you click on continue and then click on OK, tables are generated. In the first tables, the variance is calculated for these 10 participants, and the variance for the total score is 24.8. If we double click on that and then select this, right click, copy, move it to here, and we're going to paste this here, and I'm going to reduce the size. So now we have calculated the variance for the total scores. The next step is to calculate P, Q, and summation of P and Q. And to do that, first we need to transpose the data. To do that, we click on Data, scroll down to Transpose, and then I'm going to select all the data and move them into the variable section, and then click on OK, and the data are transposed in a way that the questions now in a row and the student cases are in column. And I'm going just to do some editing here to make things more neater. I'm going to decrease the decimal to 0 for everyone. I'm going to select, copy, and then paste to make them all 0, and I'm going to make all the data centered. So I'm going to select, copy, and then select, and then paste for each one of them. Select again, copy, right click, paste, right click, paste. And we're going to keep the things as scale for all the data. So we're going to make the data scale. So we have all the data in scales, and I'm going to reduce the width of the column to size number 4, and then copy this, and then select, and then paste to make them all four. So if we click on data view here, it's a little bit neater. We're going to change also the label for the variable. Instead of keeping it as variable, I'm going to label it as student. So the way to do that is to select these 10 variables, and then click on Control F for find and replace. So I'm going to click on replace, and then I'm going to type var 0 and replace it with S, and I'm going to click on replace all, and then close that. Again, we can see here, if we click on the data view, that the questions are in rows and the student or cases or participants are in column. Now the next step is to calculate the P. P is the proportion of the correct answer, and the way to calculate that is to click on transform, compute variable, and in the window for compute variables, we're going to call a new variable, generate a new variable, and call it P. And to calculate the P is in fact is the mean. Since we're calculating the proportion of the correct answer, it means the means, which is the sum of all correct answer divided by the total number of students. Here we have 10 students, and to calculate the mean for that, we click on all and then look for statistical, and then in the statistical function, select the mean, drag the mean, and place it in the numeric expression. In the numeric expression, it has a name, a mean, and followed by a bracket, and we need to insert each individual variables here for S1 into the between the brackets one by one, and each one separated from another by comma, and we need to do that for the whole 10 cases or students. And so we need to make sure that we keep the comma between after each variable. And then another comma after number 9, and then this is 10. If we click on OK, a new variable is generated for the proportion of the correct answer. We're going to ignore this value here for the total. So we can see here, this is the proportion for the correct answer achieved by individual by student for each individual question. To calculate the Q, which is the proportion of the wrong answer, click on Transform, Compute, and then reset this, and we're going to generate a target variable, call it Q. And for the Q, we're going just to use the formula, which is 1 minus the value that we had already calculated for P. Instead of calculating the wrong answer for each question and then divide that by the total number of the students, we are going to use this formula 1 minus P. Drag the P here and click on OK. A new variable is generated, which is the Q for the proportion of the wrong answers. Now the next step is to multiply the value of P with Q to generate a PQ. And the way to do that is to click on Transform, Compute Variables, Reset, and then we're going to do multiply P by Q, call the target variable PQ, and to do the multiplication is to select the P variable, then you select the multiplication symbol, then select the Q variable. Click on OK. All the P and Q variable for each individual question here is calculated. Now, following this equation here, we have managed to calculate the variance for the total score, the multiplication of P and Q. Now we need to calculate the sum of these P and Q. And the way to do that, if we are here in SPSS, click on Analyze, then click on Descriptive Statistics, then click on Frequencies. In the frequencies, we are going to select the P and Q and drag it into the variable. And we click on Statistics, and we're going to select the sum. So we're only interested in doing a sum, finding out the sum for the P multiplied by Q. The sum here is 3.42. If we double click on this table and then highlight and select and copy, and we're going to transfer this and place that here in this area, so for the value of 3.42. Now we had calculated all the necessary component of the KR20 equation or formula. The next step is to use a calculator to find out the KR20. And if we click on calculator, and in the calculator here, I am going to first of all to determine the K. The K is the number of questions in the exam, and here we have 15 questions. So K is 15, and the K in this one will be 15. So it is 15 divided by 14. And using the calculator, I'm going to divide 3.4 over 2.4, 24.8. To find the product for that is to type here in this calculator 3.42 divided by 24.84 equal to 0.1. This value is equal to 0.137. So I'm going to add here one minus 0.137. Again, if we go back again to the calculator, 0.137, so we're going to use just only 3 decimals, 0.137, and I'm going to subtract this number from 1, so minus 0.137. 7 equal, that number will be equal to 0.86. So it will be here, generate another number here, it will be 0.86. So we need to multiply 0.86 by 15 divided by 14. And we're going to do that using this calculator. So we multiply this by 1.5 and then equal, divide that by 114, then click on equal, and we have here a value of 0.92. So eventually the KR 20 for this exam, KR 20 is equal to 0.92. So this indicates that the test or the exam is 92% reliable. If we go back again here into the SPSS, these 15 questions answered, multiple choice questions answered by the 10 students, this exam is 92% reliable. And the KR20 value ranges from 0 to 1. 0 means that the exam is unreliable. 1 means that the exam is extremely reliable and extremely excellent. So this is the way to calculate and determine the KR20 reliability for exam and test that only contains multiple choice questions. And the way to do that is to use the KR20 formula by calculating the number of questions in the exam and calculating the sum of P multiplied by Q. P stands for the proportion of correct answer, Q for the proportion of wrong answers, divided by the variance of the total score. And from the value of the KR20, the exam or the test will be labeled or classified as either reliable or not reliable. Reliability tests for multiple choice question exam in SPSS using the Cron-Pax alpha formula. Reliability test measures the internal consistency of items and the scores consistency. If a same group of students repeated the same exam with the same questions, multiple choice questions at different occasions, their scores in both occasions will be similar, i.e. the exam or the test will be consistent and the scores will be consistent and the exam or test will be reliable. So there is a consistency of scores between those two occasions. So reliability test based on Cron-Pax alpha assess the exam and the test based on the equation below to determine the reliability of the test. These equations equal to K divided by K minus 1. K stands for the total number of questions, then multiplied by a bracket 1 equal within the bracket 1 minus the sum of the variance for each individual questions divided by the variance for the total score. Here in SPSS, I have a data extracted from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is recorded as either 1 or 0. 1 stands for correct answer, 0 means wrong answer. So these data here are dichotomous data. That means a binary data, only two options, correct or wrong. And to determine whether these tests that have these questions in it are reliable, so we're going to do reliability tests based on the Cronbach's alpha and based on the formula just described shortly. And to do the test, the first step is to calculate the total score achieved by each individual participant or student, and that can be done by combining all the scores for the 15 questions answered by each individual student. And to do that is to click on transform, compute variable, and then in the window for target variable we're going to call it total score. And the total score is the sum of all the scores achieved by each individual student. And to use the command for the sum, we will click on the function group all, scroll down to statisticals, and then in statisticals select the command or the function for the sum. Drag the sum to here, to this numeric expression box, and then insert the variable one by one between those brackets separated by comma. So we're going to insert the first variable and then separated by comma the second variable, and then comma a third variables, and so on until we insert the whole variables that we want to add or combine together. So we need to make sure that we keep the separate the variables with a comma when we enter them. Another comma here. 11, question 11, 12. So we need to make sure that there is always a comma between variables. Right, so if we click on OK, a new variable is generated in a column for a new variable is generated in SPSS, and I'm going just to do some editing on this variable by clicking on the variable view, and then I'm going to decrease the decimal point to 0, and I'm going to convert that measures into scale, and I'm going to center that, make it into the center, and I'm going to reduce the column into 4, so to make it neat and tidy. So now we have calculated the total score for each individual student participated in the exam, and following the alpha equation here, Cronbach alpha, we need to calculate the variance for the total score, And to calculate the variance for the total score for this variables, we click on Analyze, scroll down to Descriptive, click on Frequencies. In the frequencies, we are going to determine the variance for the total score. So we drag the total score to the variable box, click on Statistics. In the statistics box, we're going to select the variance. Click on Continue, as we're only interested in the value for the variance. An output from SPSS generate two tables. One of the tables says that we have 10 participants and the variance for the total score is equal to 24.84. So if we double click on that and then highlight that and select the numbers, copy, and then bring it here to this PowerPoint, and I'm going to place the variance for the total scores in this place here, and I'm going to decrease this by 1 decimal. So we have calculated the variance for the total score. The next step is to calculate the variance for each individual questions and then add them together. To do that, here in this SPSS, we're going to select the data and do a transpose to calculate the variance for each individual question. And the way to do that is to click on Data, Transpose, and on this small window, select Control A, select all and transfer them into the variable box, and then click on OK, and the data has been transposed in a way that all the questions now are in rows and all the students are now in columns. So I'm going to do a few editing here before I proceed with the further calculation. So what I will do, I'll click on the variable view and I'm going to decrease the decimal into 0. So I'm going to make all the values for 0 decimals, and I'm going to change the measures for each variable to scale. Every one of them, make it scale. And then I'm going to center the data into the center of the columns. So selecting this and then all centers, and I'm going to decrease the column width into, make it 4. And another modification I'm going to do is also rename the columns for the students. So to do that is to click on Control F and use the replace function, and I'm going to type VAR0 and replace that with S for students, and I'm going to do that for all the variable. And to do that, I first have to select all the variables, click on replace all, so all the variables has been renamed. Click on close, back again to data view. Now the data looks more neat and tidy. So now we have already calculated the variance for the total scores. Now we need to calculate the variance for each individual questions here, from question number 1 to question number 15. And the way to do that is to click on Transform, Compute Data, and then we're going to call that the variance for the questions. So variance for the each questions, and to do variance for each questions we're going to select the command variance from the function group. If we click on all and then scroll down to statistical, and then in statistical, in the box below, select the variance, drag the variance into the numeric expression, and again we are going to calculate the variance for each individual student. So we're going to use for each individual questions, and if we're going to use the variables from student number 1 to 10, and the way to do that again is to insert the first variable and then separate it by a comma, and we do the same for the rest. Until we reach the S10. If we click on OK, a column will be generated for the variance for each individual, calculated for each individual question. And I'm going to do some editing here for variance, is to make it center and make it scale and reduce the decimal into 0. So I'm going to get rid of this value for the totals. I'm going to keep the decimal by 2, as we are here we're having decimal, so we'll retain the decimals, 2 decimal points, so we can see the variance here. This is the variance for each individual questions. Now we need, following this formula here, we need to add all this variance for each individual questions together, and the way to do that is to click on Analyze, Descriptive, Frequency, and there we're going to select the variance for questions, drag it to the variables, click on Statistics, and then select the sum, because we are going to add all the variance for all the questions together. So if we click on Continue, then click on OK, again the variance for the 15 questions has been calculated and found to be 3.8, and I'm going to select this, or select this, copy it, and or just type it here, 3.8. Now we have most of the component required for calculating the Cronbach alpha ready. So the next step is to divide these figures to find out the product. So to do that, I'm going to use a calculator here. Using the calculator to divide 3.8 over 24.84 equal to 0.152 or 0.153. Then subtract this figure from 1. 1 minus 0.153 equal 0.847. 0.847. Then multiply this figure with k, which is the total number of questions, divided by k minus 1, which is 14, and the total number of the questions are 15 here. So 0.847 multiplied by 15 divided by 14 equal to 0.9 or 0.91. So this figure or alpha value of 0.91 means that the test or the exam is 91% reliable or 0.91 reliable. The value for the alpha or the Cronbach's alpha range from 0 to 1. 0 means that the test or the exam is not reliable, and 1, it means that the exam is extremely reliable. So in this case, 91%, the exam is reliable. So this is the way to perform reliability test in SPSS for a multiple choice question exam using the formula or the equation for the Cronbach's alpha, which is equal to k divided by k minus 1 multiplied by 1 minus the sum of the variance for each individual questions divided by the variance for the total score to get the value for Cronbach's alpha. So Cronbach's alpha is one of the method to evaluate the exam, the multiple choice exam questions quality. Cronbach's alpha in SPSS is one of the statistical methods that can be used to measure the internal consistency of items or score consistency. Cronbach's alpha value can be calculated to determine the reliability of multiple choice question exam paper. The value for the Cronbach's alpha range from 0 to 1. 0 means that the exam or the test is unreliable, and 1 means that the exam paper is extremely reliable. Here in SPSS data view, I have data taken from exam result for 10 students answering 15 multiple choice question, and the score for each question is recorded as either 0 or 1. 0 means wrong answer, 1 means correct answer. So the data here we have is a dichotomous data, i.e. binary data. There is just only two options, either right or wrong, 0 or 1. To determine and find out whether the exam is reliable, we need to calculate the Cronbach's alpha. And to do that, click on Analyze, scroll down to Scale, and then select Reliability Analysis. Click on it. In this new window, we're going to select all the variables of the questions from 1 to 15. Select A and then drag them and place them in the items box. And for the model, we are going to use the alpha, the Cronbach's alpha. In the statistic section or icon, a new window will, if we click on it, a new window will appear, and we are going to select the scale from the descriptive scale if item is deleted, and I will shortly describe the benefit of choosing this option. In addition to that, I'm going also to select the if test, and if I click on continue, then on OK, the SPSS will generate an output with few tables on it. The first table summarizes the case. So we have here 10 students, and the second table is the important table, as the SPSS package has calculated the Cronbach's alpha, and it was found to be equal to 0.91, so or 91%. So what does this value mean? This means that the test or the exam is 91% reliable. So any value for the Cronbach's alpha equal to 0.9 or greater is considered to be an extremely reliable exam, and anything close to 0 it means unreliable. So for this exam, the reliability is very, very high, and the test is consistent and excellent. In the third table here is very interesting table. It shows each question number 1 to question number 15, and in the third column here it shows corrected item for total correlation, and then the next to it Cronbach's alpha if item is deleted. So what does that mean? If question number 1 is deleted, the Cronbach's alpha will increase from 0.90 or 0.91 to 0.92. So this table shows that deleting question number 1 will increase the reliability value or the Cronbach's alpha. To test this, we're going to repeat the same analysis, but in this case we are going to deselect question number 1. So if we deselect question number 1 and repeat the same analysis and click OK, again we can see here we have exactly the same student number, but the questions or the number of the items has decreased from 15. In the above it was 15 questions, decreased into 14, as one of the item or the question has been removed from the analysis. And looking at the Cronbach's alpha value, it increased to 0.92 from a previous value of 0.91. So deleting question number 1 has improved the reliability and increased the Cronbach's alpha. So this is one of the way to calculate the reliability value and Cronbach's alpha in SPSS. If we go back again to the same set of variables, 15 questions and 10 students, if we look at this table that is labeled Anova, again in this Anova we can calculate, or I can calculate, the Cronbach's alpha. The important values to look at is the mean square. The mean square between individuals and the residual. The residual is the error. So to calculate Cronbach's alpha from this table, we're going to use a calculator. So in this calculator I'm going to use this equation: 1 minus, move this to the right here, 1 minus the value of the error residual 0.153, and then divide that by 1.65. So we're going to use the mean square for people and the mean or the mean square for error. dividing the residual by the between for the mean square of both. And if we click on equal, a value is generated which is 0.905 or 0.907, which is similar to the one calculated by SPSS in this table here. So we have here now two approaches to calculate the chrome patch alpha, that automatically generated by the SPSS or indirectly through using the Anova table here to work out the chrome patch alpha. So this is the way to determine and calculate the chrome patch alpha in SPSS and to evaluate an exam paper that contains only multiple choice questions, and to determine whether this exam is reliable or not based on the value obtained from the statistical analysis. 3 ways to test reliability of exam questions: multiple choice questions, exam paper in Excel. The first method is Couders-Richardson Formula 20 KR20 equation. The second method is chrome patch alpha formula. The third one, determine the reliability using the Anova table in Excel. Reliability test for multiple choice question exam is one way to measure the internal consistency of items or the score consistency. If a same group of students repeated an same exam with the same question or questions, multiple choice questions at different occasions or different time or different date, and the score for each individual student is similar in both occasions, then the score is consistent and the exam or the test is reliable. Reliability test can be performed in Excel using Couders-Richardson Formula 20, abbreviated as KR20. As shown on the equation here, K stands for total number of questions, summation of P multiplied by Q. P stands for proportion of the correct answer for each question. Q stands for proportion of wrong answer for each question, divided by the variance for the total score. Here in this data sheet in Excel, I have a data from an exam result for 10 students participated in the exam and answered 15 multiple choice questions. The value or the score for each question was recorded as either 1 for correct answer or 0 for wrong answer. And to find out whether this exam or test is reliable, KR20 will be calculated. So reliability test will be performed as shown here in this equation. The KR20 equals to K divided by K minus 1 and then multiplied by 1 minus summation of P multiplied by Q divided by the variance for the total score. So the first step to do the reliability test is to calculate the total score. So if we type here a label for this column, total score, and to calculate the total score is to add all the values for each individual participant together. And if we click on the symbol for sum and then select the range of the questions from queue number 1 to queue number 15 and then click on enter, a total score for each student is recorded. To calculate the total score for the rest of the student, click on the cell here, hold, drag, and until you reach the last student. So the Excel will auto calculate and auto fill the total score for each participant. So now we need to calculate the variance for the total score, and to do that we select this cell here and then insert the equal sign and then type VAR for variance. Select the first one and then select the range of the data to calculate the variance for. Click on enter. A variance of 22.36 is produced. The next step now is to calculate the P and the Q and the summation of both. So here in this cell I'm going to type P for proportion of the correct answer for the first question. And to calculate the proportion of the correct answer for question number 1, can use the mean because it is calculating these, the correct answer, dividing them by the total number. So we can use the mean here. If we click on the symbol here and select the average here mean represent the mean, and select the range of the data, the scores for question number 10, and click on enter. A P proportion value is generated for the first questions, showing 0.3 as 3 correct answer divided by 10 equal 0.3. To calculate the P value for the rest of the question, select questions, select the cell here, hold, drag to auto calculate and auto fill the value for each question. Now to calculate the proportion of the wrong answer for each question, I'm going to type Q here, and then in this cell I'm going to instead of counting the wrong answer and then dividing them by the total number of students, and I'm going to insert in that cell equal sign, then 1 minus the P value here of this cell, selecting this cell, and then click on enter. A Q value is calculated. Again, to auto fill and auto calculate the Q for AO for the rest of the question, select, hold, and drag to auto fill and auto calculate the value. So here we have the P value, the Q value. And now we need to multiply P by Q. And the way to do that is select the cell here, insert equal sign, and then select the P, the cell for the P for the first question, and then multiply that using this symbol, multiply that by the Q, selecting the Q value for question number 1, and then clicking on enter. PQ is calculated for the first questions, and to calculate the PQ for the rest of the questions, hold, drag, and the Excel will autofill and auto calculate the value. Now we have the PQ for every questions, and following this equation we need to add them up, all these values together. And to do that, click on this cell and then select the symbol for sum, and select the range for PQ for question number 1 to question number 15, and click on enter. A value of 3.42 is generated. So now we have most of the component to fill and calculate the KR20. So here we have the K, we need the K, we need the summation of P by Q, and the variance for the total score. For K, as I said, we have here 15 questions, so K value is 15. The summation of P multiplied by Q is 3.4, so I'm going to click, select, and then copy, and I'm going to paste this using the this paste. And for the variance of the total score, we have the variance here for the total score. I'm going to right click, select copy, and then place that in this cell as we saw here. Now to calculate the KR20, I'm going to use this cell, insert in it equal sign, then open a bracket, and then multiplied that by another bracket to place the equation using this equation here. So in the first bracket, I'm going to add the K value. The K value is 15 divided by 15 minus 1 equal 14. So I'm going to divide that by 14. And in the second brackets, I'm going to add 1 minus the summation of P, multiplication of P by Q. So selecting this. Once the value for the summation of P multiplied by Q is inserted, need to divide that by the value for the variance of the total score. Selecting this cell and pressing enter, a value for KR20 is calculated, and it is equal to 0.91. This value means that the test or the exam is 91% reliable. So if we look at the table here, which shows the range for the KR20 values and the measurement of reliability and labeling of the reliability, anything that is equal to 0.9 or greater is considered to be an extremely reliable test or an exam. A value for KR20 from 0.8 to 0.89 is considered to be good for reliability. Anything in the range of 0.7 to 0.79 considered to be acceptable, and the range of 0.6 to 0.69 is considered to be questionable. KR value for a test that has a range of 0.5 to 0.59 is considered to be a poor test, and a test with or an exam with a KR20 value of less than 0.5 indicates that the exam is unacceptable or unreliable. So the KR20 value ranges from 0 to 1. 0 means that the exam or the test is unreliable, and 1 indicates that the exam is extremely reliable. So this is the way to determine whether an exam or a test is reliable or not, by using the KR20 formula and determining the value using the equation. Reliability test for multiple choice question exam in Excel using Cronbach's alpha reliability test measures the internal consistency of items, i.e. the score's consistency. If a group of students, the same group of the students, repeated the same exam, the same questions at different occasions, their score or scores for both occasions are similar, and that indicate that the exam or the test is consistent and reliable. And the way to calculate the reliability of an exam as a whole or a test is to use the Cronbach alpha. This is one of the method for reliability test, and the equations for that is as given here. Alpha equals to k divided by k minus 1, as k represent the total number of questions. This multiplied by 1 minus the sum of the variance for each individual question or item divided by the variance for the total score. Here in Excel data sheet, I have a data extracted from an exam and a test for 10 students answering 15 multiple choice questions, and the score for each question was recorded as either 1 or 0. 1 stands for correct answer, 0 stands for wrong answers. So these data are dichotomous data, binary data, just two options, correct or wrong. And to determine the reliability of the exam as a whole, we're going to use the Cronbach alpha equation to generate a value for the alpha. A value of the alpha does range from 0 to 1. 0 indicates that the test or exam is unreliable, and 1 indicates that the exam or the test as a whole is extremely reliable or excellent. The first step in calculating the reliability is to calculate the total score achieved by each individual participant or student. In this case, i.e. to add all the scores achieved by each individual student. And the way to do that, in this new cell, we're going to label this cell or this column as total score, and to calculate the total score for each individual participant, select the cell, then select the sum symbol here, and select the range of the data to combine and add from question number 1 to question number 15. And if we click on enter, the total score for the first student is calculated. To calculate the rest of the scores for the rest of the student, we're going to select the value here, hold, drag to the last student, and Excel will auto fill and auto calculate the value for the total score for each individual participant. Now we have calculated the total score achieved by each individual participant. The next step is to calculate the variance for the total score, i.e. the variance for these scores. So if we select this cell and then insert the equal sign, and then type VAR for variance, and select the first options here, and then select the range of the data to determine the variance for, and then click enter. A value of 22.36 or 36 is generated. So this is the variance for the total score. The next step is to calculate the variance for each individual questions. So each one of these questions, Q number 1 to Q number 15, we're going to calculate the variance for those variables. And again, it is the same concept. If I'm going to type here variance and then select this cell, in this cell I'm going to insert the equal sign and then type VAR, select the first option here, and then select the range of the data. Select the range of the data for question number 1 to determine the variance for it, and click on enter. A value for the variance for the first question is calculated. To calculate the variance for the rest of the questions, just click on the value here, hold, drag to auto calculate, and auto fill the value for the variance for each specific questions. Now we have calculated the variance for each questions. The next step is to add them all together. So what I'm going to do here in this cell, I'm going to select this cell, then select the sum as I'm going to add them, and then select the variance for the 15 questions. And if I click on enter, a value of 3.42 is generated. This is the value for the sum of the variance for the questions. Now we have most of the component of this formula ready. For the K represent the number of questions. So here we have 15 questions. And for the variance for the total score, we have calculated that to be 22.336. Just click, right click, copy, and then we're going to paste this value using this option here. So we have now all the component for the formula ready. The next step is to calculate the alpha value. And the way to do that is to insert the equal sign and then open one bracket multiplied by the second bracket, and in the first bracket I'm going to add the K. The K is 15 divided by 15 minus 1 is 14, so I'm going to divide that by 14, and then in the second bracket here I'm going to add 1 minus the first value of the sum of the variance for the items, selecting this value here, and then dividing that by the value for the variance for the total score, and clicking the enter key. A value of alpha equal to 0.908. So this value means that the exam or the test is 91% reliable, and that is a good result and good value. So here if we look at the table, we can see that Cronbach alpha value has different ranges, and each ranges will be represented by reliability. If the alpha value is equal to 0.9 or greater, then the reliability is excellent. If the alpha value is between 0.8 and 0.89, it's a good reliability. A value of 0.7 to 0.79 is acceptable reliability. A value of 0.6 to 0.69 is questionable reliability, and an exam or a test that has a alpha value of 0.5 to 0.59 is considered to be a poor reliable exam. A value of less than 0.5 indicate that the test is unacceptable and unreliable. So this is the way to do the reliability test based on the Cronbach's alpha, using the formula given here by calculating the variance for each questions, adding them together, divided by the variance for the total score. Cronbach's alpha in Excel measures the internal consistency of items and score consistency. The alpha is calculated to determine the reliability of multiple choice question exam paper using Anova Table. Here in this data sheet in Excel, this data is a dichotomous data taken from an exam result for 10 students answering 15 multiple choice questions, and the score for each question is reported as 0 or 1. 0 means wrong answer, 1 means correct answer. So these data are dichotomous, binary, as there is only two options, correct or wrong answer. And to determine whether the exam paper is reliable, we can calculate the Cronbach's alpha. And to calculate the Cronbach's alpha, click on data, and if you don't have the icon for the data, you can generate that through the options in the file and then select the data analysis icon. Click on data analysis, a window will appear, and we are going to use the analysis tool of Anova two-factor without replication. And if I click on OK, another window will appear, and we're going to select the input range. And to select the input range, I'm going to highlight the range of the data I want to calculate the Anova for it. So we're going to leave the alpha as 0.05, and then I'm going to generate the output in a cell as highlighted here, selecting this. And then if I click on OK, two tables are generated in Excel. The first table shows the count, the sum, the average, and the variance for row 1 to 10 and column 1 to column number 15. We are interested in the second table, which is the Anova table. And the two important figures we are interested in is this figure, the means square for the rows and the means and the errors. And if I'm going just to highlight these in red, To calculate the Cronbach's alpha, use the following way. In this cell, I'm going to type alpha, and then next to it I'm going to insert equal sign, and then number 1 minus the error divided by the rows, the mean square for error divided by rows, and then hitting the enter key. Cronbach's alpha of 0.91 is generated. This figure indicates that the test or the exam paper is 91% reliable. So this table here, small tables, shows the range for the Cronbach's alpha and the reliability. Any value for the alpha equal to or greater than 0.9, then the reliability is excellent. A value of 0.8 to 0.89 indicates a good reliability. A value of 0.7 to 0.79 is acceptable reliability, and Cronbach's alpha value of 0.6 to 0.69 indicates questionable reliability, and the value of 0.5 to 0.59 is considered to be a poor reliability, and anything with a value of less than 0.5 for alpha is considered to be an unacceptable exam or test, i.e. unreliable. So this is the way, one of the way to calculate the Cronbach's alpha and determine the reliability of an exam paper, sorting it out either as extremely reliable and excellent reliability, or an unacceptable, unreliable exam. Two methods to calculate item discrimination for multiple choice question exams in both SPSS and Excel. Those two methods are Kelly's equation method and point by serial correlation coefficient. Two methods for item discrimination analysis in SPSS for MCQ exams. Those two methods are, first one is Kelly's equation method. The second one is point by serial correlation coefficient. Item discrimination analysis in SPSS based on Kelly's equation. The analysis will evaluate and identify multiple choice exam questions that are good or bad in discriminating between high performing students and low performing students. So this analysis is only designed for multiple choice questions, and the analysis is based on an equation generated by Kelly's to determine the item discrimination or the question discrimination. And the way to do that is to calculate the total scores for each individual participant achieved in an exam, and then group the student into an upper group and a lower group. The upper group contains top 27% of the total score, and the lower group includes lowest 27% of student total scores. And then proportion can be calculated for the upper and the lower, and a percentage can be generated for each individual item or question. and the value for the item discrimination can be from -1 to +1. Here in this SPSS data view, I have a result from exam and the test for 20 students participated in this exam that included in it 20 questions, 20 multiple choice questions from 1 to 20, and each individual student answered the multiple choice questions, and their answers are recorded as either 0 or 1, given a value of 0 or 1. 0 represent wrong answer, 1 represent correct answer. And from those 20 questions, we aim to determine which one of these questions are good questions and which are bad questions, in distinguishing between excellent students and low performing students. And to do the item discrimination analysis, it is a multi-step. The first step is to calculate the overall mark, or the total mark achieved by each individual student, i.e. to add up all the correct answer recorded by each individual student, add them up and generate a new variable, call it total score. And to do that, we click on transform, compute variable. In this new window, I'm going to generate a target variable, call it total score. And in the total scores, I'm going to add all the values within each individual cell together. So i.e. add all these multiple variables for each individual student together to generate the total or overall mark. So we need to use the sum function in this case. And the sum function, to get the sum function, click on all, scroll down to statistical, and then click on sum, drag the sum command into the numeric expression. A numeric expression, the sum is followed by a bracket. So we need to enter or transfer each one of these questions or variables into the bracket, or between the bracket, and separating each question by a comma. So if you click on the first one and then add a comma, click on the second one, transfer, comma, and then third one, and so on. And since we have here 20 exam questions, I had already generated these questions labels in Word document, type them, and I'm going just to select them and copy them, and then insert them or place them in between the brackets. So if I delete that, add the bracket again, and Control V or paste. So all the 20 variables have been placed in between the brackets, separated by a comma, and this will instruct the software to add all the values for each individual student, to add them up together and generate a new variable called total score. If we click on OK, again we'll see here that a new variable is generated called total score that has in it the overall mark achieved by each individual student. And I'm going just to edit the column a little bit by removing the decimal point and making it 0, making it at the center, and then since it is a marks and this is a scale, it's measured at a scale. And then I'm going to reduce this, keep this up to 66, so to reduce the column. So now to continue with the item discrimination analysis, we need to rank those overall mark or scores in a descending order from high to low. So we're going to click on data, sort cases, and we are going to sort the cases by the total score and in a descending order from high to low. Again, as we can see here, the data are rearranged that we have the highest score achieved by student are 17 out of 20 and the lowest is 8 out of 20. The next step in SPSS is to rearrange the data to be able to manage to calculate the upper group and the lower group. So we are going to use a function called transpose, in which we transpose these questions from being in a column into a row and swap the students' numbers and IDs, swap them from rows into columns. So it is a reciprocal swapping. So if we click on data, scroll to transpose, and then we are going to transpose all the variables with even the total score into the box of variable, and we're going to name the variable, move the student's ID into name variable, and if we click on OK, a new window appears showing that the questions has been transposed into rows and student IDs had been transposed into columns. Again, as this is for question number 1, 3, 9, 19, and 2, similar to the original 1, 3, 9, 19. It's just only it has been transposed. I'm going to do a little bit of editing here as the width of the column is large, so I'm going to reduce it a little bit to do a little bit of editing. So I'm going to change first of all the decimal into 0 for the copy for all the data we have here, for the value of the value or the scores within each cell. And I'm going also to change the column width as it's too high for 12, so we'll keep it at 6, give it a 6, and this is also 6. And see if I can copy it, and if I can drag it and change it for all, if I click Control V, again it has changed the column to 6, number 6, and again align them into the center, so keeping the data within the center of the cells. And for measurement, we're going to change that into scale. For all the data. So when we look at the data view, it is much neater and much better. We could reduce it more, but that's more than sufficient. Again, if we look at the total score, the order and the rank is kept also constant, hasn't been changed since we have done the ranking. So now we have first of all calculated the total score, ranked the data, and then transposed the data. The next step is to group these students into upper group and lower group and calculate the proportion in each. And for the upper group, it should contain top 27% of the student total scores, and the lower group lowest contain lowest 27 of the total score. And since we have here 20 students, and if you use a calculator, though we don't need a calculator, it's just only we have here 20 students, and we need to generate a group that has 25%. So we will multiply that by 27%. 27%, that will generate 5.4. So we will convert that to integer. So we will put in the upper group 6 scores, overall scores from 6 students, and in the lower one overall scores from 6 students, again in the low performing student. So in this case, so we're going to generate upper group that includes 6 overall grade from 6 students, and the lower one overall grade from another 6 students that are performing poorly. And the way to do that is to generate again here a variable, call it upper group, lower group. So compute variable, generate a target variable, call it upper group, and the upper group, again we can see here the order is and the rank is kept in place. So K1, as we can see here, is the highest mark or the highest total score here. The first 6 has the highest total score, so we're going to select 6 from K1, 1, 2, 3, 4, 5, 6 up to K4 here. So what we will do here is to click on brackets here, move the first value from the variable K1, and then add a plus sign, then add the second one, and then another plus sign, a third one, a fourth one, a fifth one, a sixth one. So we have here top grade or top overall scored from the top performing student. So this is the upper group, and we're going, since we have selected 6 students, divide that by 6, and if we click on OK, a variable generated here for the upper group for all the 20 students and the 20 questions. Now, to generate the lower group, we're going to do the same thing, but we're going to select the lowest 6 scores. So here are the lowest 6 from 1, 2, 3, 4, 5, 6. So starting with 7, moving 7, adding plus sign, and then this variable, plus sign, this variable, and then the next one. We haven't moved the 11th, and then we move the other one, and then the next one, and finally the last one. So we have here 1, 2, 3, 4, 5, 6 variables moved into between the bracket, and we need to add them up and then divide them by 6 to generate the lower group. So here we are calculating the lower group, and if you click on OK, and again another variable is generated called lower group. The next step in generating and calculating the item discriminating IT is to subtract the value from the lower group from the upper group. And again, to do that, we click on compute variable, and I'm going to reset that and call it ID. And instead of retyping the whole thing, you just click on upper group, put the minus sign in between, and then lower group, and then click on OK, and ID or this item discrimination is generated here. We're going to ignore the value for the total score from our calculation, but what is genuine here is that this is the ID score, and the ID value should be between -1 to +1. So we could see 0 value here, and as we can see here, a 0 value, and a 0 value here, and a minus value here, and a positive value of 0.5. So if we take the first example here or the second one, -0.17. -0.17 indicate that there is something not correct with the question. The question is, in this question number, let's say, which question is this? Question number 2. Low performing students are answering the questions correctly, and high performing students are answering it wrongly. So this question has to be removed from the exam, as it is not discriminative. It does not distinguish between high performing and low performing. Now, the other thing is that also the question number 3 has a value of ID value of a 0, and that is indicate that this question is not discriminating between high performing or low performing, as they both scored the same on this analysis, ID analysis. Again, the same thing for question number 4. If we scroll down here, again, this is a question number 16, and if we show from question number 16, it has a positive value, and it is 0.83. This is a very high value, which indicates that this is a very good question, that it can discriminate between excellent students and poorly performing students. So anything, the rule for ID analysis, the rule for it, that anything above 0.25 up to 0.39 is considered to be a good question. Anything above 40%, 0.4 and above is considered to be a extremely good question. So this question is extremely good. This question, again, this question, though it is positive, but the score or the value for it is 0.17, which is less than the standard. The standard for classifying questions has to be above 0.25 and above to 0.39, but in this case it is below 0.25. Thus, this question is a poor question in discriminating between high performing and low performing. So this question is poor questions. This question is a poor one. This one is a good one, very good one, very good one. This is good. This is bad one. This is good, very good, very good, good, and so on. So this is the way to do item discrimination analysis in SPSS for a multiple choice questions, and it is of a great benefit and use for those who designing an exam or an assessment for students and want to evaluate the power of discrimination of the questions. an ability of the questions or the item to discriminate between high performing and low performing student. The way to do that is, one of the way to do that is to do an item discrimination analysis based on the formula formulated by Kelly's equation. So the way to do that is to rank your data into in according to the overall scores from high to low, and then in SPSS rank them, first calculate the total, then rank them, then transpose your data, and then calculate the upper group proportion, lower group proportion, and then subtract them from each other to generate the ID. We could also, in addition to calculating the ID in this way, we can also generate an ID percentage. The way to do that is to go to compute again, and we are going to call it percentage. And to do the percentage is to select the ID, drag it here, and then multiply that by 100 to get a percentage for the item. Again, as we can see here, this item is 83% discriminative. So this is the way to do item discrimination analysis in SPSS using Kelly equation. Good or bad MCQ questions. Whether you are an educator, a teacher at school, or a lecturer at college, or a professor at university, and you are frequently involved and participate in exam questions design, and you repeatedly design multiple choice question exam paper, and you want to look at the questions and determine which one of these questions are bad and which are good, which of these questions discriminate between the student of high performing student and low performing student. The way to do that is to use item discrimination analysis or question discriminating analysis in SPSS based on using a point by serial correlation coefficient. A point by serial correlation coefficient is a statistical test that is used to find the relationship between two variables or two sets of data. And I'm not going to describe the background and the criteria and the conditions in which to use the point by serial correlation coefficient in it, as I've already described it in a separate video, and I have uploaded that on my YouTube channel, and I'm going to leave the link for the video in the comment box, so feel free to have a look at it. But here I will just show you how to do the statistical test and how can you tell and determine and identify a good question or a bad question. Here in SPSS, I have a data for an exam question for 38 students answering 76 questions, multiple choice questions. So we have here 76 variables, 76 columns, or 76 items. These questions can be called items also. And the score or the value for each question for each individual student answered is recorded as either 0 or 1. 0 stands for wrong answer. The student has or had answered the question wrongly, and 1, the student had answered the question correctly. And to determine which of those questions are good and which are bad, we need to do a statistical test called point by serial. But we need first of all to do two steps. The first step, we need to calculate the overall total mark for each participant or each student achieved. So we need to generate a column here for the total overall exam mark or total exam score for each individual student. So we are going to generate a column here for that, and we are going to calculate that in percentage. So we're going to add all the scores or the value for each of those 76 questions for each individual student, add them together, divide them by 76, and then multiply them by 100. The way to do that is to click in SPSS, to click on transform, compute variable. Again, there are three ways to calculate the total exam score or the overall exam mark. First one is you click on bracket, drag the first variable, click on plus, second variable plus, and then plus, and so on and so on until you move all the questions in between the bracket from question number 1 to 76, and then divide that by 76 as we are adding them up, and then dividing them by 76, and then multiply them by 100. So this is one of the way to calculate the total exam score. The other way is to click on function group all, then scroll down to statistical, and then from statistical choose the sum command and drag it to the numeric expression. Again, you have the sum command and then a bracket, and we need to move the first variable separated by comma, second variable separated by comma, third variable separated by comma, and so on and so on until you enter the 76 variables in between the bracket. Then you need to divide that by 76, multiply that by 100. So this is the second way. The third way, which I am going to use here, is to use the mean function. Again, so we need to generate a target variable. We're going to call that target variable over all marks. Overall marks, and again we're going to move all the scores, all the variables, all the items and with their score in them into the bracket one by one, separated by comma to generate the mean. So we have here 76 items or variable, and I had already typed this in Microsoft Office, and I'm going to copy it from here, right click and then copy, and then paste it into the in between the brackets, so to save me time. So they are there to use whenever I need them. So here we have the mean, and in between the bracket the variables or the items from question number 1 to question number 6. And to calculate the overall mark, i.e. the percentage, I need to multiply this by 100. As of already here, the average has been calculated. And if we click on OK, a new column is generated, or a new variable is generated, which has the overall mark or the percentage of each student achieved in the exam. So here now we have 76 variables, and and overall exam marks. So, and we want to identify and determine which questions are good and which question is bad using the point by serial correlation. So the next step is to do a point by serial correlation coefficient. Here, as we can see, we have these questions and we want to find the relationship or the association between question number 1 with the score in it and correlating that with the overall mark. So to determine whether this question is good or bad, whether it is discriminative or not. And we need to do this for all the 76 questions together simultaneously. So each one by one, comparing each questions with the total mark. So we have here 2 variables. The first variable is the item or the questions, which is categorical because it only had a score in it 0 or 1, category 0 and 1, right or wrong, 0 wrong, 1 is right, and the continuous variable, which is the percentage. So here we can use the point by serial correlation coefficient. And the way to do that is to click on Analyze, scroll down to Correlate, then to by Variance, because we are all looking at here by mean 2, variate mean variable, 2 variables, and I'm going to reset this. Again, we have here the 76 questions or items, and we want to correlate each one individual one with the overall mark to calculate the point by serial value or coefficient. Click on Control A to select all the questions with the continuous variable and drag it into the variables. And we're not going to change anything here, keep it as it is, but we make sure that we use here the Pearson correlation coefficient test, as the point by serial correlation coefficient test is based on the point by serial is based on the Pearson correlation coefficient. If we click on OK, an SPSS will generate a correlation matrix for question number 1 to question number 76, correlating this intercorrelation between each items and correlating them with the overall marks. So we are interested in this column here, or sorry, in this row here at the bottom, and on the final column, which is titled as, labeled as overall mark. And again, if we look at the final row here, which says that overall marks, Pearson correlation, and then it's give a Pearson correlation value and significance of that value. Again, for which is again Pearson correlation represent point by serial. For point by serial correlation, the value is from -1 to 1 to +1. -1 indicates it's a negative relationship, and +1 it means a positive relationship. And the higher the value, the stronger the relationship. Again, and for purpose of analysis of this test, for the point by serial correlation, we set the value that anything below 0.15 value for point by serial, the question or the item is poorly designed, or a poor question, or a bad question. Anything above 0.25 is a good question, and anything higher, it is a very good question. However, simultaneously, we need also to look at the statistical significance. Anything below any value for p-value for the test below than 0.05, then it is statistically significant and the correlation value is significant. In the first example here, we can see that the correlation between question number 1 and overall mark is 0.22. That's considered to be fair question. However, it failed to be statistically significant, so we will consider that questions probably considered to be a bad question. Again, the same thing for question number 2. The p-value is 0.36, so it is less than 0.05. Again, this question is not statistically, the value for it is not statistically significant, so this question is also a bad question. However, for question number 3, the p-value is 0.029, which is less than 0.05, so it is statistically significant, and the correlation coefficient is 0.35. This is a really a good question that can discriminate between students. Again, a fourth question is 0.5. This is a very good value or coefficient, and the statistically significant. The fifth question is 0.7. The value for the coefficient is 0.76, and this is really a very high value. So this is really a very, very good question. And the sixth question here, as we can see, the point biserial correlation coefficient is very close to 0, so it's 0.054. Anything that is close to 0 or 0 is indicate that the question is not discriminating between students, so it is not a good question, so it is a bad question. Meanwhile, also the value for the statistical significance is greater than 0.05, so this question is really a bad question, and so on and so on and so on. So this is the way to determine which question is good and which question is bad. And if I want to save or export this table, which I'm going to do, and I'm going to export the data, the table or the outcome for the statistical analysis for the point biserial into either Excel file or Word documents or PowerPoint or even as a PDF. And I'm going to export this table here, the correlation matrix, as a Excel file. And the way to do that, click on the table and then right click on export, and then another window will pop up, and I'm going to select Excel 2007 and higher, and I'm going to call it again point biserial, saving it, and I'm going to keep the tick for open the containing folders once the file is exported. If I click on OK, it says that it already exists, so I'm going to overwrite it. So the file is exported into the Excel in a format of an Excel file which have the correlation matrix in it, and in this occasion I am only interested in this row. So what I'm going to do is I am going to select the rest and delete it, but I'm going to need, I'm going to keep the question number 1, but I'm going to questions or items, and I'm going to delete the rest. So I'm just only interested in the correlation between the questions and the total marks. Let's make sure that I have everything here set up correctly. So if I right click, select, and then right click and delete, and then click on OK, I will have here the correlation between questions and the value of the correlation and the significance. So I'm going to get rid of the first column and get rid of the last column as it is the number only, and I'm going to rename this, instead of Pearson correlation, point by serial, as it is based on Pearson correlation. So I have here the point by serial for every individual questions in your exam paper, and I'm going to get rid of this column as it is no need for it. So we have the p-value and the value for the coefficient. So anything with statistical significance and a higher value indicate that the question is good, and anything below it is bad. Here there is an interesting observation. I need to mention it. In one of the data here, let me look for it, minus. There is a minus point by serial. Minus indicate that high performing students are answering the question wrongly, and low performing students are answering it correctly. So in this case there is something wrong with the question, and it's the best way is to remove the question and replace it by another question. So this is one of the benefits of doing discrimination analysis, item discrimination, using the point by serial correlation coefficient, as it will highlight the question, which question has problem in it, or which question is bad and which question is good. Again, I could also take this data here, copy all the 3 columns or just the 2 columns here. I'm not interested in the first. Copy, and then I had this data in a Excel file. I could also here I have it here somewhere in exam question. I could add it to the data I had already for this exam result, and I could add the Pearson correlation here at the end of the either in columns or in row, and I do prefer it in row here. Again, as for every question by serial correlation, this is question number 1, and this is the point by serial value, and this is the significant value or the p-value for the question. So in this way I had shown you how to determine which question is good and which question is bad based in exam, based on item discrimination and analysis using the point by serial correlation coefficient. Two ways computing item discrimination in Excel for MCQ exams. Those 2 ways are Kelly's equation and a robust way of using point by serial correlation coefficient. Using Kelly's equation in item discrimination analysis to evaluate multiple choice exam questions in Excel, to identify questions that are good in discriminating high performing students from low performing students, and to classify the questions as either a good question or a bad question, following the equation of item discrimination equal to upper group minus lower group divided by 27% of the total students. And we're going to perform the analysis in Excel. Here I have a data from an Excel sheet from exam result for 20 students answering 20 multiple choice questions from question number 1 to question number 20, and the score for each question is recorded as either 0 or 1. 0 is the wrong answer, 1 is the correct answer. So here we have a categorical data, dichotomous data, two possible categories, 0 or 1. And we want to determine the item discrimination for the 20 questions to determine which question of these are good and which are bad based on the analysis. And the first step to do the item discrimination following the equation proposed by Kelly is to calculate the total score or the overall mark achieved by each individual student. So we are going to generate here a column and we call it overall mark. And to calculate the overall mark for each individual participant, we need to add the score from all the questions from Q1 to Q20 all together. And the way to do that, click on the cell here, insert equal sign, then type sum, select the sum formula, and in the sum formula drag the range of the data to calculate the sum from Q1 to Q20. A value is calculated, 17. The grade or the mark, the overall mark for the first student is 17. And to calculate the rest, we just need to drag and hold and drag the value to the last student. So to auto calculate and auto fill the value for the overall mark for each individual student. So we've calculated the overall mark. The next step in item discrimination is to arrange or rank those overall mark from high to low, from descending in a descending order. And the way to do that is to click on the data itself, select the whole data, and then click on sort filter and use custom sort. In the custom sort, make sure that this my data has headers is ticked, and we're going to use the column which is labeled overall mark, as this is our reference for doing the item discrimination analysis and a reference for ranking the data from high to low. And we're going to rank the data in the order of the largest to the smallest. If we click on OK, again we can see here that the software has arranged the data from the highest to the lowest. So the lowest score by students was 8 out of 20, and the highest is 17 out of 20. Now, following the arrangement of the overall scores in descending order, we need to generate the upper group and the lower group. So we're going to type here upper group, lower group, then ID for ID discrimination, and then ID percentage. And to calculate the upper group proportion and the lower group proportion, we're going to use the ranked value on the overall mark. And for the upper group proportion, we need to select the top 27% of the total student who achieve total marks. And for the lower group, select the lowest 27% of the total score. So student who scored lowest. So we have to generate two groups, and the number of the student to select will be equal to, if we have 20 questions or 20 students, and we want to arrange them into upper and lower group, and we want from the upper group to include 27%, then we multiply that by 27 to get a value of 5.6, which will be approximated to 6. So each group, upper and lower, each one of them will have 6 students in it. The scores for the 6 students, for the upper and the lower group. And to calculate the upper group values, and I'm going here just to highlight this, divide these groups, this data into upper and lower. So if I select the first top 6 students and label them, give them a label of green, as this is the upper one, and the lowest group 6, select from it as lowest 6 students. I'm going to keep it red. Now what we want to do here for the upper value, we need to insert the equal sign and then type sum and select the sum formula. In the sum formula, we are going to select the first 6 values here in for Q1, close the bracket, and then open another bracket and put the sum formula in a bracket, and then divide that by 6 since we have 6 students. So this is the way to calculate upper group proportion. If you click on enter, the value is generated. And we're going to do the same for the lower group. In the lower group, we're going to insert the equal sign and then type sum. And then we are going to select for question number 1 the 6 values, the lowest 6 values here, close the bracket, again doing the same thing, put the sum formula with the value in brackets, divide that by 6 as the lower group has 6 students in it, press enter, a value has been generated. Now to auto fill and auto calculate the value for the rest of the group of the questions from Q2 to Q20, we're going to select, select the first row, drag it to calculate and autofill the value for the upper group, and do the same thing for the lower group, select and auto and drag to the last question number 20, and a value is generated for the upper and lower group. So here we have now upper group and lower group, and the next step to determine the item discrimination is to subtract this upper group from the lower group from the upper group. And the way to do that is click on insert, click on the cell, insert equal, select the first value here from the upper, then select, then put the minus sign, and then select the lower group and then click enter. A value is generated for ID there. So this is the item discrimination for question number 1. Again, drag and select and drag to autofill and auto calculate for the rest of the questions. So here we have the value for item discrimination for the 20 questions. I'm going to decrease the decimals to make it a little bit by clicking on cell format and then number decimal. We're going to make it, change it, or make it, keep it 3, or even I'm going to change it to 2 to make it much easier to compare. Item discrimination value range from -1 to +1. A very good question has a value 0.4 or greater. A good question has a value of 0.25 to 0.39, and the bad question had a value of, or a value less than 0.25. And also ID value can be 0, or even it can be from 0 to -1. So those are all the possible range of value from -1 to +1. In the first cell here for question number 1 for the ID value is 0.33. This is a good question, as it can discriminate between high-performing student and low-performing student. The second question has a ID value of 0. 0 means that the question is not discriminating between high-performing and low-performing, so this is considered to be a bad question. So 0 indicate the question is bad, and 0 indicate the question is bad, and question number 4 also, so question 2, 3, 4 are bad questions, and they ought to be removed or excluded from the exam, or rewritten in another way that the ID for it will be higher. For this question number 5, the ID is 0.5, which is really a very good value, and this question is very good as it is greater than 0.4, and this question is very good in discriminating between excellent student and poor performing student. In this also ID value for question number 6, the value is -0.17. This question is discriminating between high performing and low performing, but the low performing students are scoring the questions correctly, and the high performing students are scoring the question wrongly. So this question ought to be removed from the exam, as it is not discriminating, and omitting it from the exam is the best way to get rid of it. Others value here, we can see here there is a question which is number 16, has a value of 0.83. This is a very good question, in fact an excellent question in discriminating between high and low students. Question number 19 and 20 and question number 13 has an ID value of 0.17, which is below the range here. Anything less than 0.25 is considered to be a bad question. So this one and this one and this one is a bad question, ought to be removed from the exam, and this one -1 is also ought to be removed from the exam. These 0 value for the ID are bad questions, that they do not have the power to discriminate between high and low performing student. So this is the advantage of using item discrimination analysis based on the Kelly's formula, as it will permit identifying and evaluating questions and determining which questions are good, which are very good, which are bad, to remove from the test. Here, as we can see, out of the 20, 1, 2, 3, 4, 5, 6, 7 questions out of the 20 questions for the multiple choice for this exam are a very bad questions that has to be removed from the future exams. So this is the way to do an item discrimination analysis in Excel. First you have to calculate the overall score, arrange the overall scores in ranks from high to low, and then group the student into upper and lower group and calculate the proportion in each group, and then determine the ID value for each question. We could also do a ID percentage by inserting in this here equal sign and then selecting this and selecting the ID value, multiplying it by 100 to generate the percentage of the ID, and we auto-fill and auto-calculate for the rest of the questions, and also we can reduce the decimal point here to something manageable and easy to recognize. So this is the benefit and the advantage of using ID for assessing multiple choice exam questions. Assessing the quality of multiple choice questions in an exam sheet by evaluating the ability of the MCQ or a question, its ability to discriminate between a high performing student and low performing student, i.e. measuring the power of each individual questions in its ability to differentiate between good students and high quality students and low performing students, based on evaluating each specific questions, whether it is a good questions or a very poor questions that probably require replacing or removing. The way to do that is to use an item discrimination analysis in Excel based on point by serial correlation coefficient. Again, this assessment of the questions is of a great benefit for those who are involved in education and designing exam sheets or paper, and to want to make sure that the questions serve the objective of their subject or taught modules in a way that it will fulfill the requirement for and it assess the learning objective of a module. So doing an item discrimination analysis is an important step in assessing exam questions, multiple choice questions. I have generated, as I said before, a video clip describing what is point by serial correlation coefficient and the background for it. For those who are interested, feel free to look at the video in my YouTube channel. Here in Excel, I have entered a data from an exam result for 38 students answering 76 multiple choice questions from question number 1, Q1 to Q76, and each individual or each student answered the questions, the data recorded or entered as either 0 or 1. 0 stands for wrong answer and 1 indicates correct answer. So each questions has a value or a score of either a 0 or a 1 answered by each individual student. 1 for correct answer, 0 for wrong answer. So here in these questions we have only 2 types of scores, 0 or 1, which will indicate that it is a categorical data, so just 0, 1, 0, 1. And if we want to evaluate each questions and look at the quality of each multiple choice questions of those 76 questions, and the first step to do that is first of all to calculate the overall exam score for each individual student, or the total score that each individual participant had achieved in the exam. And the way to do that is to scroll here to the far right, and I'm going to generate a new column, and I'm going to call it total score. And the way to calculate the total score is to add up all the value or the scores for each individual participant has achieved for all the questions, 76 questions. Add them up, the value for them, then divide them by 76 and then multiply them by 100 to calculate the percentage of the correct answer or the total score, which we are going to use these scores in subsequent analysis. And the way to calculate that is if we just click on the cell here and then click on the symbol here indicate. We can use two methods here, either using the sum, adding up all the value, or use the average. And I'm going to use the sum method, in which I'm going to select the question number 1 to question number 76 as it's showing here, equal sign sum P2 to PY2, and I'm going to divide that by 76, since we have 76 questions, and then multiply that by 100. So the total score or the percentage of the mark for each individual student for the exam, first one is 82. And if I select and drag the cell toward the end, it will autofill the total score for each individual participant or student. So here we have 76 questions scored as either 0 or 1, and a total score of 38 students, and the scores in a percentage. So here we have a categorical data for each one of these questions, 0 or 1, and a continuous data percentage from 0 to 100. And to determine which one of these questions is discriminative between students or not, you need to do a point by serial correlation coefficient. And point by serial correlation coefficient is based on Pearson correlation coefficient. And to do the analysis, we need two sets of data. The first set is dichotomous or categorical, as we have here the questions, and the second one is the continuous. So we need continuous, which is the total score. So we need to correlate and find the relationship between each individual question with the total score. So we need to study the relationship, calculate the relationship through a statistical test of point by serial between each individual question and total score, and to generate a value for the correlation, and this value indicates the strength of the relationship. And the way to do that in Excel is if we click on data and then click on the data analysis. Either way, if you don't see the data analysis icon on your Excel sheet, the way to bring it on is click on more and then go for options and then scroll down to add in, and then scroll down here to manage add in, and click on this analysis toolbar, which will make the icon appear here. So if we click on the data analysis, and then I'm going to, here we have a list of tools or tests to use, and we're going to select correlation, since we are looking at correlation, and this will use the Pearson correlation coefficient. If we click on OK, the window appears, and we are going to input the range. So we are going to compare, correlate the data, the total score with all the 76 questions. Then we need to click on this arrow, and I'm going to click here, then scroll to the beginning of the up to Q1, and then hold the shift key and click on Q1. Again, the data that we need to include is highlighted, and then click again on shift control and on the below arrow. This will select all your data that you want to correlate the total score with all the questions. And if we need to keep this label in the first row ticked in, and we're going to generate the correlation in a new worksheet. If we click on OK, again a correlation matrix is generated, as we can see here, in which each question, so you look at the bottom one here, each question is correlated with the total score. Total score correlated with the question 1 up to question 76. So now here I'm going to rearrange and delete the data that I don't want. So I'm going to get rid from this row up to 76. So by holding the shift key, click, and then right click on it, I'm going to select delete. Again, this will delete the other data that we are not interested in. So here what we have is the correlation between question number 1 and total score or overall mark, and question 2, 3, 4, and so on. And to rearrange the data in a much better way, we highlight this row, then right click on format the cell, and I'm going to click on number, and I'm going to use only 3 decimals to make the value here easy to compare. So here from this data we can see that we have the correlation coefficient for all the 76 questions, and each question has a value. I'm going to get rid of the last one because it's correlating total score with total score will be 1. So to delete this one. So now we have the value, the coefficient value, the point by serial coefficient value for all 76 questions. And in fact, I want just to color code those value so that will be much easier to look at the data. So if I highlight the row for total score and then click on home and then click on conditional formatting, then click on new row, and in the new row I'm going to use a 3 color scale, and I'm going to change the type into number for all the minimum, the midpoint, and the maximum. And I'm going to enter here as a -1, since the range for the point by serial coefficient is from -1 to 1. So I'm going to keep the midpoint 0. The maximum 1 is here is 1, and I'm going to change the color. For the minus, we need to make it red. For 0, which is, I don't want to make it white, as it is does indicate no correlation. And for the maximum 1, put the color coded with a green. If I click on OK, and here again color coded, all these cells are color coded again according to the value within it. As we can see here, that the higher the value, the more greenish the cell will be, as here the correlation coefficient is 0.76, and here is a poor correlation of 0.15, and here also a 0.05, and also interesting really toward a pinkish, toward reddish color, which is indicate a minus correlation, and here also a minus correlation. Now, what does this value mean? This value means that if you have a value of P, I'm going to call this point biserial, as this is the point biserial now, and then I'm going to make it a little bit darker. So what does this value mean? Indicate that the closer the value to 1, the stronger the correlationship between each questions and the total mark. So in this case, anything above 0.15 is a fairly good question, or anything from over 2.25, it's a good question, and anything over 0.4, it is a very good question. Any value close to 0, as here, it's indicate that there is no correlation between the question and the overall score, i.e. this question is not discriminative. It doesn't discriminate between high performing and low performing students. So this question needs addressing either by remodifying it, rewriting it, or excluding it and removing it from the exam sheet. A negative value here indicates a problem, as it is minus 0.294. This indicates that high performing students answered this question wrongly and low performing students answered the questions correctly, which doesn't make sense. So there is something wrong with these questions, and the best way for it is to exclude that question and remove it from the exam. And also similar things to this, also question number 70, as it's also negative. So negative means it is a bad question. So it's to get rid of this, anything close to 0 or minus need to be removed, and as it doesn't discriminate between individuals. So this is the way to discriminate between questions and find out which questions are good and which questions are bad, which questions to keep and to use in the future exam sheet, and which one to replace or rearrange or rewrite. Now, this value here for the point biserial, although it is, some of these values are high, but again, this value has to be statistically significant, has to be confirmed by calculating the p-value. So p-value for each correlation between questions and overall score is need to calculate the p-value, as the p-value is the determinant factor in the significance of the relationship between the questions and the overall score. So to calculate the p-value for each individual questions, correlation of each individual question to total score, is to click on, if we go here again to this data, and we want to calculate the p-value, I'm going to select some. Unfortunately, in Excel, we only can do it one by one questions by one. So we need to calculate the p-value for question 1, and then question 2, and then up to 70, question number 76. So I'm going to select question number 5 here and calculate the p-value for question number 5, as the p-value here for question number 5 is 0.76, which is very high, but is it significant? And the way to find out the significance is to calculate the p-value. To calculate the p-value for number 5 here, need to click on the data, then icon for data analysis, then scroll down here on the list and use the regression. We are going to use the regression to calculate the correlation between these two variables to get a p-value. So if you click at OK, and in this window we are going to enter a data for y-axis input. In case it is a correlation, it is a regression, then you have y-axis and x-axis, and it's a correlation between them, and then calculating the p-value. For y-axis, we are going to use the score data here, as it is selected, total score, as this is the overall mark. And for the input, again, we're going to select that. We haven't selected that. If I click on this here, and then hold the shift, control, and down arrow, it will select just only the data and the label for that column. And we'll do the same thing for input. For the input X range, I'm going to use calculate the p-value for question number 5. So I want to scroll to number 5, click on it, and then hold the control shift and then arrow indicating to the lower arrow, and then click on here again. As you can see that number 5, let's do it again, double check. So if we go for number 5 here, click shift and then black arrow, it's selected here as we have seen here, 5 and arrow column 5 is selected, and then click on label, and we are going to generate the output in a new worksheet. If we click on OK, here a few tables are generated. What is important here in this tables is we need to look at just only the question number 5 here. I'm going to highlight that with the yellow color, and of all this, what is interesting to us is the p-value. This p-value, as it is, again, this video look like a little bit complicated, so we need to change the format of the cell to a much easier decimal point, change it to 3 decimal point. Again, as we can see, this is the p-value correlating question number 5 with the overall mark, and the p-value for it is 0.00. So question number 5 here, if you go back again to the MCQs, question number 5, and here in this sheet, question number 5 has a p-value which is equal 0.000. So again, we need to set up this for the format of the cell into 3 decimals, so we need to see the decimal. Click on OK. I see the decimal. So this question number 5 is really an excellent question. First of all, it has a high value for the correlation coefficient 0.76 away from 0 toward 1, and a statistically significant p-value which is 0.000. And for the p-value, for anything to be statistically significant, the p-value has to be less than 0.05. This is the cutting point. Anything less than that, then the value we are looking at is significant. So it is significant or important value. Anything below 0.05, this is significant. Then this value of 0.76 is a significant value, which means that this question number 5, is a very good questions, a very excellent questions to keep for discriminating between students. I will also look for another example here, and I'm going to look at question number 6. As we can see here, the correlation value is 0.05, which is close to 0, which might indicate that this question is a bad question. Again, we need to calculate the p-value for it, as without p-value we cannot really make a conclusion on the quality of these questions, as the value for point biserial by itself is not enough to judge without the p-value. So we need to find out the p-value, and to find out the p-value, again we go to the MCQ, the sheet, original sheet, or data. It has data in it, and then data analysis, and then regression again, and we are going to use keep y axis or input y range as the total score, and the X range, we're going to select number 6. If I select, then Control Shift and below arrow, and then click on here, click on label, keep it as it is, and click on OK. Again, another regression tables is generated. We have to do again the same changes. Change this into, format the cells, change it into 3 decimal points. The p-value is 0.79. If we copy this and we go here to this 0.7 and place it here, 0.749. Again, if we look at the p-value for here, it's very high. It is above 0.05. So once we see this value here, so we have to reject this value, this reading or this value from correlation coefficient, and we say that this questions is poor questions, and we should not consider this questions in the exam, as the correlation is very low and at the same time it is non-significant. Now, one last point before finishing, I want to pick up a negative question. I'm going to do the same thing for negative question. Here for question number 47, we have a correlation coefficient minus, which indicate that the question is not discriminating, as in this question, high-performing student answer this question wrong, and low-performing students answer it correctly. So we need to find out whether this question is worth considering. Again, if it is minus, then it does not worth considering, and it's worth removing it. It is important to remove this question as it is not discriminative. But again, we had to determine the p-value for this correlation value, which is minus 0.294, and the way to do that again is to go to the MCQs and then click on data analysis, regression again, changing that into selecting now the data number or question number 47, click, Control Shift, below arrow, and then click on OK. Again, another table is generated here, and as we can see here, the value, again changing these things into formatting the cell, so making it 3 decimal points, copy MCQs, and going to our first sheet here, and we're going to place the value here. Again, this is the p-value for this test when we correlate question number 47 with overall scores. It gave us a minus 0.29 value and a p-value of 0.07. Again, this value is greater than 0.05. So in this case, we discard these questions, as the correlation is not significant, and it is essential to remove this question from the exam. And again, you have to do these steps one by one for all the rest of the questions. You need both the value for the coefficient and the p-value to make your judgment on the question. So this is the way to do the analysis item called item discrimination or question discrimination analysis, to discriminate analysis that will discriminate between high performing and low performing based on the questions, evaluating the questions using a point by serial correlation coefficient value with a p-value for it, statistical significant value for it. So this is the way to judge whether a multiple choice question is a good or bad question, and this can be of a tremendous benefit to those who are involved in education and assessment and designing exams that is of a high quality and high standard 1. Item difficulty analysis in SPSS and Excel for multiple choice question exam to determine the p-value for each question and to identify questions that are easy and questions that are difficult based on the equation given below. Item difficulty equals to number of students answering item correctly divided by the total number of students multiplied by 100. Item difficulties measures the proportion of students who answered a question or an item correctly. Sometimes it is referred to as a p-value. P stands for proportion. The item difficulty value range from 0 to 1. 0 indicates that no student has had answered the question or the item correctly, so it is an extremely difficult question. And item difficulty of 1 means that all the students had answered the question correctly, so it is a very easy question. And the way to calculate the item difficulty is to count the number of the student who answered the item correctly and divide that by the total number of students participating or taking the exam. And to get the percentage, multiply that by 100. Here I have a result of an exam or a test for 38 students who had answered 76 multiple choice questions, and their score was entered as 0 or 1, 0 for wrong answer, 1 for correct answer. And to calculate and determine the item difficulty for each question and to determine which question is very easy, which question is very difficult, which item is ideal and acceptable, we will follow the formula just described previously. So I'm going to type in this cell p-value as we're going to calculate the p-value or the item difficulty. And to calculate the item difficulty, I'm going to insert the equal sign and then type sum and then select the sum function and then select the range for the first question. So we are going to select the scores for item number 1 for student 1 up to student number 3 and 38. And then we close the bracket, and then we're going to insert also a bracket between the sum and its range. So as we are going to divide the sum by the number of the total number of the student participating in the exam, which is 38. So this the formula or the equation, adding all the value on the for the items for each student, their score, whether it is correct or wrong, and then divide that by 38. And if we click on the enter button or enter icon, the item difficulty value is calculated. To reduce the decimal, I'm going to select only 2 decimal points for this value. For the first item or questions, the value for the P is 0.18. And to autofill and auto calculate the item difficulty for all the remaining 75 multiple choice questions, select and drag so that toward the end of the column, that column ends for question number 76, and the Excel will auto calculate and fill the item difficulty for each question. Again, we can see here that each question has its own way of measuring its difficulty through item difficulty. To make things much easier, also I'm going to color code those values using the table here, small table, taking in consideration that the ideal question that has a difficulty, item difficulty range from 0.4 to 0.6, and I'm going to increase it a little bit here, taking a value of 0.4 to 0.66. So to color code these values, select the row first, and then click on the conditional formatting, scroll to new rule, and then in the select rule type, click on the format only cell that contain. So in this format, I'm going to color code only cells that has specific value. So cell value, I'm going to use a range between 0.4 and 0.66. So what I'm going to do here is color code anything between 0.4 and 0.66, and I'm going to give it a color by clicking on format and clicking on fill. And since this is what we want to select, I'm going to click on the green color. And if I click on OK again and click here on OK, all the values that has a range between 0.4 and 0.66 is color coded as green, and green indicates that this is an ideal question. This is a questions that is really good to use in the exam. Now for the rest, which is of course the rest will be either very easy or very extremely easy or extremely difficult. Again, we're going to do the same. Click on conditional formatting, scroll down to new rule, and then click on format cells that contain. Again, the same thing. Instead of selecting between, not between, so we're going to use exactly the same value, 0.4 and 0.66. So any value that is not between 0.4 and 0.66, I'm going to color code that by clicking on the fill and give it a red color, meaning that this question is either it is very easy or very difficult. Click on OK, and then click on OK again here, as we can see that each item has its value for difficulty, and each difficulty is color coded. Red for very easy or very difficult, and green is an ideal or acceptable questions with acceptable difficulties. To calculate the percentage of item difficulty, insert the percentage and then into the cell next to it, going to insert the equal sign and then select the value of the item difficulty for question number 1, multiply that by 100 and press on enter. A percentage of the item difficulty is calculated, and I'm going to decrease the decimal point to just 1 decimal point. And to calculate the percentage of item difficulty for the rest of the multiple choice question, just select, drag to autofill and auto calculate the value for the rest of the questions. Again, here the percentage of item difficulty is calculated with the p-value for each item. Here on this side, a small description for the range of the item difficulty. Any item or questions that has a p-value or item difficulty from 0 to 20 is labeled as a very difficult questions. From 20 to 40 is difficult. From 41 to 60 considered to be moderately difficult. 61 to 80% is easy, and 81 to 100% is considered to be a very easy question or an item. If we look at the item difficulty percentage for question number 1, we see that the value is 18.4%. Using the value here, a range of the value, this question is very difficult, as only 18.4% of the students answered this question correctly. So this question is extremely difficult one. And question number 2 next to it has a value for item difficulty of 95, nearly 95%, which indicate that 95% of the students participating in the exam answered this question number 2 correctly. So this indicates that this question is extremely very easy question. The one next to it is just on the border between an ideal question. Ideal question has a p-value range of 0.41 to 60, as shown here, 0.41 to 60. So this one is just on the border of being considered to be an ideal question. The one next to it is nearly 79% item difficulties, which indicate that this question is a very easy question, and so on. So we're looking at analyzing the item difficulty for the rest, and looking at this one here, saying it's 57%. That's an ideal question. The one here, 81, is very easy. This one is an ideal question. So this is the way to sort out and label the questions in an exam paper as either very easy, ideal questions, very difficult or difficult questions, based on the item difficulty calculation. Item difficulty analysis in SPSS is one of the methods to evaluate the quality of multiple choice question exam. Item difficulty measures the proportion of students who answered the question correctly. Sometimes it is referred to as p-value, stands for proportion or percentage value. Item difficulty value range from 0 to 1. 0 means that no student had answered the question correctly. So the question is an extremely difficult one. And an item difficulty of a value of 1 indicates that all the students had answered the question correctly, and the question or the item is an extremely easy question. The way to calculate the item difficulty value is to count the number of students who answered the question correctly, divide that by the total number of students participating in the exam, and then multiply the product by 100 to get the percentage or proportion of the value for item difficulty. Here in this sheet of Excel, I have an exam result for 38 students answering 76 questions, from question number 1 to question number 76. Those are multiple choice questions, and each question, the score for it was either 0 or 1. 0 indicates wrong answer, 1 means correct answer. And to determine which one of those questions is an easy and which one is a difficult, then we need to perform item difficulty. First, we need to copy these data and transfer it into SPSS to do the analysis in the SPSS. So to do that, click on the question number 1 and then drag and then scroll to the end toward question number 76. Hold 76, hold the shift key and click, and those questions from 1 to 76 are highlighted. Then click on shift together with control and with the arrow that's heading toward the bottom, and this will highlight the data that we want to transfer. Once these data are highlighted, right click and then select copy and then transfer this into SPSS in a new window of data view. Click on this cell and then right click and then paste the data from Excel into SPSS. And here I'm going to do a few editing and modification. I'm going to delete the first row, and if we look at the variable view, we need to do some editing for the changing the type of the data and lining the data and the measuring for the data, and also naming the variable. We'll start with the type. So since we have here a value of 0 or 1 or a score of 0 and 1 for each question, then we need to change this from a string into numeric. And the way to do that is you click on the cell here, 3 dots appear, click on them, and then a window appear here specifying what type of variable you want to select. So for this we're going for numeric. We click on OK, and we do the same for the rest and so on. So I've missed the first one, so I'm going to also change the type to numeric. And since once we started here, we can also select the cell and then copy and then select the cells that we want to change the type, highlight them, then right click and then paste. All these cells has been changed to a numeric. Now for the align, again you click in the align, 3 options appear. I'm going to make it center. For the second one also center. For the third one also center. And to make it faster, I'm going to copy the first one, highlight and select all the one that I want to change, and then paste to make them all center. And for measure, again we're going to keep it as scale at this stage. Now for naming of the variables, they are all named from variable 1 to 76, and I'm going to change that naming. So if we highlight that column here, all the variable, and then click Control F for replace, find and replace, a window will appear for find and replace variable. And in the find, I'm going to type VAR000, and then I'm going to replace anything with VAR variable 000 with Q for question. And I'm going to do that for all the variables. So we replace all the variables. So we click on replace all, and as we can see here, all the variable name has been changed into Q number 1 to Q number 76 with the 38 cases. Now we are ready to do item difficulty analysis straight away. The way to do that is to click on Analyze, scroll down to Descriptive Statistics, then scroll down to Descriptive. In the descriptive, we are going to calculate the item difficulties for all the questions. So we're going to select all, Control A, and then drag into the box of variables. Under the options, click on the options and take the minimum, the maximum, the standard deviation, and keep the mean, because the mean in this case is the total amount of the correct answer divided by the total number of students participating in the exam. So the mean reflects here the item difficulty. So click on continue and then click on OK. The SPSS will generate an output, a table from question number 1 to question number 76. And in this question there is a mean for each question, which is the average of the correct answer for every individual item or question. So this is the value here is the item difficulty or the p-value, and it could be changed into percentage by multiplying it by 100. As a standard rule in calculating and evaluating item difficulty, any item which has a value for item difficulty between 0.41 and 0.6 is considered to be an acceptable, an ideal, and a moderate difficult question. Anything below 0.41 and or higher than 0.6 is considered to be either a very difficult or a very easy question. So here for the question number 1, the item difficulty is 0.18, which means 18% of the student answered this question correctly. So it is a difficult question. In fact, it is a very difficult question. The question number 2 has a value of 0.95, or 95% of the student answered the question correctly. So this indicates that the question is extremely easy question. Question number 3 had a value of 0.39, just on the border of 0.41. So we'll consider that as an acceptable question. Question number 4 has a value of 0.79, 0.8, 80%. So this indicates that this is an easy or extremely easy question. Question number 5 has a value of 0.66. Again, this one will be included in the category for moderately difficult question. So we'll accept that as an acceptable question. So if you scroll through all, we can see here there is 92% of the student answered the question correctly. So this is the way to identify and determine which question is an easy question or extremely easy question, and which question is an extremely difficult question or a difficult question. And so this way an examiner will be able to identify the question, modify them or change them, and make the exam quality of a high standard for the students. And to transfer this table, I'm going to export this table into Excel and save it as an Excel file. And the way to do that is to click on the table as it's highlighted in yellow, and then right click on it, and there is a function for export. Click on that export, and I'm going to export that table into Excel, which is 2007 and higher, and I'm going to save that in the folder for YouTube under exam questions, and I'm going to save it here as item difficulty. Choose the item difficulty here and save. Item difficulties, and I'm going to save it in under item difficulties, and then if we click on item difficulty and save it here, and then we made sure that this box for open the containing folder is ticked on. If we click on OK, again it will be exported and the file is saved in item difficulty in the folder.